Look and see what we've got here, Dean.
Once you've identified the shapes of containers and read their markings, you need to collect and communicate detailed hazard and response data before taking action.
1203.
According to NFPA 472, operations level responders must quickly verify information from at least 3 sources, communicate any dangers, and mitigate hazards. To help you understand this process, your learning objectives are to reference hazard and response information, understand material behavior terminology, understand health hazard terminology, predict the behavior of a material in its container, and use this information to estimate the potential harm to responders and the public. Once you have read visible placards and collected data about the containers on scene, NFPA 472 requires that you reference at least 3 separate sources of information to confirm the identity of materials involved and how to mitigate their dangers. The first source is the Department of Transportation Emergency Response Guidebook, also known as the Orange Book. It has been created for first responders to access in the initial phase of an incident. The Orange Book provides information on every hazardous material transported in North America. The guide requires you to take 3 steps to access information. Step 1 is to identify the material by either using the 4-digit ID number on a placard or orange panel, using the 4-digit number on a shipping document or package, or by finding the name of the material on a placard or package. Once you have located these markings, step 2 is to look up the material's 3-digit guide number in either the ID number index, which has yellow bordered pages that list dangerous goods in numerical order along with the correct guide number, or the name of the material index that has blue bordered pages. These pages list dangerous goods in alphabetical order, followed by the guide number and ID number. If you identify a material whose guide number is followed by the letter P, it may undergo violent polymerization if it is subjected to heat or contamination. Also, if the index is highlighted in yellow or blue, it is a toxic inhalation hazard or dangerous water-reactive material. If this is the case, look for the ID number and name of the material in the table of Initial Isolation and Protective Action Distances in the green bordered pages. This section lists warfare agents, water-reactive chemicals, and toxic inhalation hazards. Then, reference the Protective Actions Guide. Step 3 is to match the guide number with the material in the orange bordered pages. The orange section is the most important in the guide because it describes potential hazards, suggested public safety measures, and recommends emergency response actions, including first aid. It will also provide detailed information about the chemical. If a numbered guide cannot be found using these steps and a placard can be seen, use the table of placards, then go to the 3-digit guide shown next to the sample placard. Like any other tool, it is important to know how to use and interpret this book correctly before you arrive on scene. A second source of response information is a Material Safety Data Sheet, or MSDS. OSHA requires an MSDS be located where materials are stored, at the security gate of a facility, or in the cab of a transportation vehicle. There are several sections within the MSDS to provide a complete picture of a chemical's potential behavior and characteristics. Section 1 is the Chemical and Company Identification Area. This names the material and relates the MSDS with the label and shipping documents. It also includes the mailing address and phone number of the manufacturer and distributor. Section 2 indicates the composition of the material's ingredients. Section 3 is the Hazards Identification section. This describes the material's appearance, odor, and health hazards. Section 4 lists first aid measures, potential routes of exposure, and typical symptoms. Section 5 is for firefighting measures. This section describes the fire and explosive properties of a chemical, as well as firefighting instructions and extinguishing media. Section 6 describes accidental release measures. It provides information on how to prevent adverse effects on people, property, and the environment, as well as cleanup information. Section 7 describes handling and storage procedures. It will tell you how to minimize hazards from temperature and atmospheres when a material is stored. Section 8 is for suggested exposure controls and personal protection. It will tell you types of defensive actions and the forms of PPE that should be used and its suggested limits. NFPA 472 requires that you know how to access and understand each of these sections of an MSDS as one of your resources. The third source of response information is the Chemtrek system. Chemtrek provides vital hazardous material information over the phone 24 hours a day at 1-800-424-9300. It has one of the largest MSDS databases in the world and can put you in touch with product specialists and chemists. Chemtrek can provide information about the effect of exposures as well as medical response procedures. When you contact Chemtrek, be prepared to provide your name and phone number, the name of the material shipper or manufacturer, the shipping paper information, and the type of incident, including local conditions. Chemtrek is an outstanding resource for verification and even provides service in other languages. Canutech provides the same service in Canada, as does CTIC in Mexico. In addition to using the DOT Orange Book, MSDS, and Chemtrek, you also should know how to access the names and numbers of all local agencies that are a part of your area response plan. These numbers should also include agencies equipped to deal with terrorism. The more information you have, including that which has been verified by 3 distinct sources, the more effective your planning and response will be. Understanding the terminology associated with hazardous material behavior is the responsibility of first responders at the operations level. This will enable you to better understand MSDS and communicate with other responders and agencies. The first term NFPA 472 requires you to know is boiling point. The boiling point is the moment at which the vapor pressure of a liquid is equal to or greater than the atmospheric pressure. The MSDS lists this information under the Physical and Chemical Properties section. The next term is chemical reactivity. This represents how a material will react when mixed with other chemicals. Understanding this term will help you determine if materials may undergo dangerous changes, such as polymerization. Reactivity is located in Section 10 of an MSDS. The next term is corrosivity. This describes the ability of a chemical to eat away at materials. Corrosivity readings will help you determine if irreversible damage to tissue or containers can occur. Flammability is the potential of a material to ignite or burn. You can determine flammability by using the ratio between vapor and air that allows for an ignition. Flammability information is available in the Firefighting Measures section of the MSDS. Flashpoint describes the minimum temperature at which a liquid produces an ignitable vapor. The Firefighting Measures section of an MSDS will include flashpoint information. The ignition temperature, also known as autoignition, is the temperature at which a material ignites on its own. This is also listed in the Firefighting Measures section of the MSDS. The physical state tells you if a material is a liquid, solid, or gas. The MSDS will list this information in the Physical and Chemical Properties section. It will greatly influence how the container will behave under stress. The specific gravity of a material will determine whether it will sink or float in water. Water has a specific gravity value of 1. The vapor density expresses whether a vapor will rise or fall in the air. Air has a vapor density value of 1. The chemical properties section of the MSDS will provide some of this information. Toxic products of combustion are the fumes and smoke created by a material when it burns. This information can be critical if the scene includes a fire. Vapor pressure is the pressure a material exerts on a closed container. This is significant in helping you predict the amount of vapor that could be released from a container. Vapor density can also help you determine a substance's ability to produce vapors in its current environment. This can be a factor in determining defensive measures and decontamination. Water solubility determines whether a material will blend uniformly in water. This can be a factor when loads become mixed. And radiation is the energy that moves in the form of waves or particles. When accessing information, speaking with Chemtrek, or talking with other responders, you need to know these terms to communicate with precision and efficiency. It will also help you predict the behavior of a material within its container. When you are assisting victims who have been affected by hazardous materials, your team needs to communicate effectively by using the appropriate terminology. Very often, these terms will express what treatments to use on victims and how to protect yourself. One fundamental concept is to be able to differentiate between an exposure and contamination. An exposure is when someone has been subjected to or has been in the presence of a dangerous material. Even exposure to small amounts of certain substances, such as corrosives or biological agents, may present a significant hazard. To be contaminated, a person must be physically stained or polluted by a substance. Contamination could come in the form of touching, breathing, or eating a dangerous substance. Furthermore, secondary contamination should also be defined as a part of your response plan. Secondary contamination occurs when someone who has been in direct contact with a dangerous material transfers it to someone or something else. This can easily occur when packaging contaminated patients or handling contaminated equipment. Radioactive material exposure and contamination are other important terms to be aware of. There are 4 primary types of radiation exposure: alpha, beta, gamma, and neutron exposure. Particles emitting alpha radiation need to be inhaled or ingested to pose the risk of radiation sickness. Most alpha exposures come from smoke detectors and other sources. Beta rays can be stopped by almost any solid material, but are dangerous if the radioactive substance is ingested or inhaled. Beta rays are also capable of passing through skin. Gamma rays have much higher energy and can pass through the body easily. They can affect organs such as the liver and kidneys and cause radiation sickness. Neutron rays are the result of fallout from an atomic blast, which can easily be inhaled or swallowed. Radiation can be found in various facilities and presents a serious health risk if not properly planned for. Knowing each of these terms will help you communicate efficiently with your responders as well as with other agencies. When you are responding to an incident involving containers, it is important to know what types of stress can cause them to fail and how it will impact your response. An important size-up tool in this process is the interruption principles model. The premise is that stress and harm are the keys to determining a size-up. Identifying the source of stress and finding ways to eliminate it can often prevent a release. If you cannot mitigate the stress, you will likely have to deal with a breach. Types of stress include thermal stress, the application of heat or cold to a container, This can occur due to poor placement of containers within a facility or exposure to weather. Mechanical stress, the stress caused by an impact such as a container being dropped, this often happens when containers are moved with a forklift. Chemical stress, the stress caused when a product can produce reactions that may defeat the integrity of a container. Although certain drums are able to hold corrosives, they may only be able to do so for a limited amount of time. When stresses on a container are extreme or remain unchecked, a breach may result. The most common breaches are punctures or closures that fail, such as when a piece of equipment pierces a storage tank or when a cap or valve fails. There are various types of releases related to a breach that you need to be able to recognize as well. Release types include detonation, violent rupture such as a levee, rapid relief, and spills or leaks. If a release does occur, you need to know how materials will disperse in order to minimize the threat to the incident area. Materials can disperse in several ways, often described by their dispersal shape. Dispersal shapes include hemispheres, where vapors are symmetrically dispersed by detonation. Clouds, where vapors escape all at once in a rapid relief. Plumes, where vapors follow natural openings in a continuous long-term release. Cones, such as when gamma rays escape through a container breach. Streams, when heavier materials or liquids follow the natural contours of the ground. Pools, where materials gather on the ground near the container. And irregular releases, such as when materials are spread by subjects or responders. With so many variations of containers, it is extremely important that you understand the behaviors of hazardous materials as they are stored and how they could impact your response. When preparing for a hazmat incident, one of the most important things is to recognize the potential for serious health hazards on scene. The first step is to understand the relationship between the nature of the material and the length of time a person can be exposed to it before their health is affected. Knowing the terminology used to express exposure levels will help you understand this relationship and tell you how to begin treatment for victims. The first term is permissible exposure limit, or PEL. PEL expresses allowable exposures to a material in an 8-hour day or over a 40-hour week that is appropriate for 95% of healthy adults. Recommended exposure limits reflect a ceiling level of exposure over a 10-hour-a-day, 40-hour work week. Both represent the amount of materials someone can be exposed to without adverse effects. The next term is short-term exposure limit. STEL represents a 15-minute exposure with an hour break before additional 15-minute exposures. This value is often seen in industrial settings where workers are near dangerous materials. No more than 4 exposures are allowed per 8-hour day. Another value responders may see is the lethal dose exposure rating. LD50 describes chemicals that can affect people by any route other than inhalation. Lethal concentration, or LC50, represents inhalation exposures. Both warn that 50% of a laboratory test population died at that level of exposure. These values should warn you to use extreme caution. After you have identified the material and have determined its concentration with an air monitor, you must reference an OSHA or NIOSH guide to determine exposure values. This will help you select the correct PPE and tell you what type of treatment will best serve affected victims. These determinations will also help you recognize how a chemical may be affecting victims. Some of these chemicals are generically named by how they affect people. Asphyxiants are chemicals that can cause unconsciousness or death by suffocation. Chronic health agents affect people over a long period of time. Convulsants that produce spasms, sweating, and high temperatures. Irritants that produce skin rashes and irritation. Sensitizers produce allergic reactions and affect the sense of smell. And radiation, which can produce nausea, vomiting, and diarrhea. You also need to be able to recognize the effects of exposure to chemical weapons. Nerve agents such as sarin, soman, and V-agent kill people by affecting their nervous system. Vesicants such as mustard gas create skin and eye irritation, as well as respiratory and digestive difficulty. Blood agents such as hydrogen cyanide can cause seizures, comas, and severe dizziness, and eventually kill victims through asphyxiation. Choking agents such as chlorine cause severe coughing, nausea, vomiting, and burning, among other symptoms. Irritants like tear gas often cause severe burning in the eyes and skin and may hinder breathing. Another type of weapon is the biological agent. An example would be anthrax. There are 3 variations of anthrax. One that enters the victim through inhalation, one through cutaneous exposure, and the other through gastrointestinal ingestion. All are extremely deadly. The amount of time that victims are exposed to these agents and their distance from the source will guide how you prioritize the use of emergency medical assets. The amount of shielding in front of a victim will also impact exposure from radioactive materials. Knowing how hazardous materials impact the health of bystanders will help you assess and communicate this critical information at the incident scene. As a firefighter on the scene of a hazardous materials incident, collecting information will help you determine how to improve scene safety. It will also be the foundation for any treatments and defensive actions. In this program, you have learned about collecting hazard and response information, predicting the behavior of a material as it relates to its container, understanding exposure ratings, and estimating potential health hazards to responders and citizens. Your ability to access information is critical when you are responding to a hazmat incident. By meeting the standards in NFPA 472 at the operations level, you will know how to properly react in a given situation, effectively communicate with your team members, and work with other responding agencies.